we present MaPLe, Multi-modal Prompt Learning. This work focuses on foundational vision language models such as CLIP. These models are trained on large corpus of image-text pairs with contrastive objectives and learns the joint vision language representation space. These models are open vocabulary in nature and are highly generalizable towards downstream tasks. In this work, we address the challenge of effectively adapting CLIP for downstream image recognition tasks in few shot and zero shot settings while maintaining CLIP generalization. One naive way is to undergo full fine-tuning of CLIP, which is not trivial. The scarcity of data and massive size of CLIP poses risk of training instability. Also, such fine-tuning can lead to overfitting and losing CLIP original generalization performance. Existing methods have taken inspiration from the NLP domain and proposes prompt tuning to adapt CLIP. These methods append learnable prompt vectors at the language branch of CLIP while the rest of the model is kept frozen. Despite being effective, these methods adopt only the language branch of CLIP and thus proposes unimodal solution, while CLIP is multimodal. These models ignore the adaptation of visual branch and thus adapt CLIP partially. We argue that prompting should instruct the model completely for better transfer. We propose MaPLe, a multimodal prompt learning approach for CLIP. Our approach MaPLe adjusts both the visual and language branches of CLIP via multimodal prompts. Additionally, we introduce hierarchical deep prompts across various transformer blocks in the vision and language encoders of CLIP. This allows the learning of stage-wise feature relationships for rich contextual learning. In order to establish the explicit interaction between the visual and language prompts, we propose vision-language coupling function, which conditions the visual prompts on the language prompts. We introduce multimodal language and visual prompts which are appended with the text and image inputs respectively. The prompts are learned hierarchically across transformer blocks of both encoders. Further, the visual prompts are conditioned on the language prompts via the vision language coupling function, which is implemented as a linear projection layer. We show TSNE plots of the image embeddings from the CLIP image encoder. The image embeddings of MaPLe are more separable across categories as compared to the unimodal solutions. This demonstrates the importance of adapting CLIP image encoder in addition to adaptation of language encoder. We conduct experiments across three different benchmarks, namely based on novel generalization, cross-dataset transfer, and domain generalization experiments. In based on novel generalization benchmark, MaPLe shows significant improvements over previous state-of-the-art method CoCop on both base and novel classes, leading to the highest harmonic mean of 78.55%. MaPLe also retains the generalization of pre-trained CLIP by providing highest novel class accuracy. Next, we show the comparison of MaPLe in cross-dataset transfer setting. We note that MaPLe performs favorably well against previous approaches on most datasets, which leads to the highest average accuracy of 66.3%. In the domain generalization benchmark, MaPLe shows favorable performance on out-of-distribution datasets. In this work, we highlight the issue of partial prompting of CLIP, which leads to suboptimal downstream task performance. To address this, we propose multi-modal prompt learning paradigm, which dynamically adjusts both the language and vision representation space of CLIP for better transfer. Further, we propose multi-modal hierarchical deep prompting to progressively learn the prompts across different transformer blocks for better stage-wise contextual learning. Vision language coupling function allows mutual synergy between the language and vision prompts by conditioning the vision prompts on the language prompts. Across three diverse generalization benchmarks, MaPLe consistently improves the generalization of pre-trained CLIP. Thank you.